All right, let's just jump right in. We all like to think we're rational, right? That our decisions are the product of some careful, logical process. But what if I told you that most of the time, your brain is just running on autopilot, taking these little mental shortcuts that can lead you, well, wildly astray? Today, we're going to pull back the curtain on the hidden biases that are constantly shaping your reality.
So let me just ask you straight up, are you really in control of your thoughts? It feels like a simple question, doesn't it? But the answer is so much more complicated than you'd think. Because deep down inside your mind, there's this constant tug of war going on.
So let me introduce you to the two main characters in your head. First up, you've got System 1. Think of it as the hero. It's lightning fast, totally intuitive, and it's always on. It's your gut reaction. And then there's System 2, the detective. This one is slow, deliberate, analytical, and honestly, it takes real effort to get it to do anything. System 1 is amazing at making quick sense of the world, but here's the catch. It does that by jumping to conclusions. And that right there is where all our thinking traps begin.
And that leads us perfectly into our first set of biases, what I'm calling the storytelling trap. This is all about System 1's obsession with creating a neat, tidy, confident story, even when it has almost no information to go on. Let's see what that looks like in action.
Okay, check this out. It's a surprising fact. In the United States, the counties with the lowest rates of kidney cancer are overwhelmingly rural and sparsely populated. Your mind, your System 1, it immediately starts searching for a reason, right? You're thinking, oh, it must be the clean air, or the fresh food, a healthier, less stressful life. It makes perfect sense.
But wait a second, here's another fact. The counties with the highest rates of kidney cancer are also mostly rural and sparsely populated. Whoa, now your brain is totally scrambling. How can that be? Is it poverty, a poor diet, no access to good health care? The stories you're telling yourself are in a complete head-on collision.
So, how on earth can both of these statements be true at the same time? It seems impossible, right? Well, the answer has absolutely nothing to do with lifestyle and everything to do with a sneaky statistical trap. This is a classic example of something called the law of small numbers. The really crucial piece of information, the one we almost always overlook, is that rural counties have small populations, and small samples, just by their very nature, produce more extreme and unstable results than large ones. It's just random statistical noise. But our System 1 is absolutely desperate to find a cause, a story, where none actually exists.
Let's try another one. Picture this person, Linda. She's 31, single, really outspoken, and very bright. In college, she majored in philosophy and was super concerned with issues of discrimination and social justice. Okay, now, which of these is more probable? A, Linda is a bank teller, or B, Linda is a bank teller and is active in the feminist movement? Go on, take a second. If you're like most people, you overwhelmingly chose B.
And if you did, you just fell right into the conjunction fallacy. See, your System 1 absolutely loves the plausible story. Option B just feels right. It feels more representative and coherent with everything we just heard about Linda. But if you stop and engage your slow, logical System 2, you realize it's a statistical impossibility. Think about it. The group of all bank tellers has to be bigger than the smaller subgroup of feminist bank tellers. It's a classic case where we confuse what's plausible with what's probable. Okay, so our brain loves telling itself stories, but it's also really easily misled by outside information, which brings us to our next big section, the influence trap. This is all about how our judgments can be totally manipulated by completely random, irrelevant details.
I've got a quick question for you. Was Mahatma Gandhi more or less than 114 years old when he died? Now, I know, that's an obviously absurd question. Of course he wasn't. But just by me saying that number, 114, something just happened inside your brain.
Okay, now for the real question. Go ahead and take a guess. How old was Gandhi when he died? Whatever number just popped in your head, I can almost guarantee you it was influenced by that first, ridiculous number I threw at you. And the research on this is crystal clear. When people are given a high anchor, like 114, their average guess is way higher than when they're given a low anchor. I mean, both groups are way off from the actual age, which was 78, but you can literally see how that first number, the anchor, drags the final estimate right along with it. It's wild. This is the anchoring effect, and it works in two ways. First, your fast system 1 is subconsciously primed by the number, it just latches on. Then, even if your rational system 2 tries to adjust away from it, that adjustment is almost always way too small. It's an incredibly powerful trap that gets used everywhere, from salary negotiations to the price tags you see at the mall.
All right, now for a totally different kind of influence. Imagine you're in an experiment. If you're in group 1, you're asked to list 6 examples of a time you were assertive. For most people, that's pretty easy to do. But if you're in group 2, you have to list 12 examples. And that is much, much harder.
So, after they're done, which group do you think ended up rating themselves as being more assertive? The one that actually listed more examples, or the one that found the task easier?
You're not going to believe this. It was the group that only had to list 6 examples. So why? It's because, for our brains, the feeling of ease when you recall something often matters more than the actual amount of evidence you come up with. Because those examples came to mind so easily, their system 1 just jumped to the conclusion, wow, I must be a really assertive person. That, my friends, is the availability heuristic in action.
So our intuition doesn't just fail with stories and suggestions, it's especially terrible with statistics. This next trap explains why we're always seeing patterns and causes in what is often just pure random chance.
Take this scenario from the Israeli Air Force. A flight instructor notices a pattern. Whenever he praises a student for an exceptionally great landing, their very next attempt is almost always worse.
So naturally, the instructor comes to this very firm conclusion. He says, I've learned that praise is ineffective and punishment works. When I criticize a bad landing, the next one is almost always better. I mean, it sounds like a solid piece of evidence-based wisdom, doesn't it? But it is completely 100% wrong.
What that instructor was actually witnessing is a fundamental law of statistics called regression to the mean. All it means is that after any extreme performance, whether it's unusually great or unusually terrible, the next one is simply more likely to be closer to the average. That's it. The praise and the criticism had nothing to do with it. But our storytelling brain just can't accept that. It needs a cause and effect explanation.
Okay, so if our brains are just these minefields of thinking traps, what are we supposed to do about it? We can't just turn off our intuitive system 1. We need it to survive. But we can learn to recognize its tricks and deliberately engage our analytical system 2 to think a whole lot smarter.
So how do we actually do that? Well, here's a simple but incredibly powerful 3-step method. First, always start with the base rate. What's the statistical average? What usually happens in this situation? Second, go ahead and form your intuitive prediction based on the specific evidence you have. Make your gut judgment. But third, and this is the absolute crucial part, you have to consciously adjust your intuitive prediction back toward that average. This one simple correction helps you account for randomness and stops you from making predictions that are way too extreme. Look, the world is a noisy, random place, but our brains are hardwired to see patterns, stories, and causes everywhere we look. So the real takeaway here is this. The next time you feel absolutely certain about something, just pause. Force your inner detective to take a closer look. So I'll leave you with this. What obvious truth are you going to question today?